Hey guys, it's Miss Miklos, and since I could not be with you guys today, I decided to make a video for you instead. So first thing I want you to do, if you haven't done so already, go ahead and go into Blackboard and open up the note handout for this chapter. Today we're going to be talking about sections 4.1 and 4.2, and they really go together quite well, so it makes sense to do them on the same day. Obviously today, as you can tell, we are talking about trigonometry, and what you will see is a lot of this stuff in this chapter is very similar to some things that we did last year in Algebra 2. I'll let you know, by far the biggest difference is that this year we will definitely have more of a focus on radians versus degrees. Okay, so last year when we had anything in radians, most likely you converted it into degrees right away and thought of it in that sense. Today, we're going to start trying to think in terms of radians so we can directly do our math in that fashion. So just a reminder, trigonometry is really just the study of angles. And you guys started this all the way back in geometry, and we really looked at a lot of triangles. In Algebra 2, we did more of angles that were graphed. And just a reminder of what an angle is. An angle consists of two rays with a common vertex. Okay, so here we have a ray, and then we have another ray, and we can see that they come together at a vertex. So whenever we are graphing these, we are going to use what we call standard position. And so I'm going to go ahead and label this standard position just so we are aware of what we're doing. As I'm writing, you guys can write as well. And some things we know about standard position, there's actually three different aspects. First, we put what we call our initial side on the positive x-axis. So I'm going to go ahead and put what we call our initial side. It's kind of tough to read for some reason, but there we go. On the positive x-axis. Notice my vertex is at the origin, and we call our other side the terminal side. And the terminal side, it really depends on where we need to graph our particular angle. I'm just going to go ahead and put it like right here. Okay, so that is our terminal side. So this is an example of kind of what we're used to seeing when we're graphing. Let me make that a little bigger. There we go. That looks prettier. Okay, some other things that I just want to talk about are direction. We're really used to positive angle measurements, and that means that we are moving counterclockwise. And you guys should remember that from last year. So I'm going to actually draw a little arrow. And whenever we're graphing these, we should be showing an arrow that just indicates direction. If we are working, and I'm going to change colors here just because I want to. There we go. If we are working in a negative angle measurement, so I'm going to write this over here, negative, we move clockwise. So I'm going to go ahead and draw an arrow that indicates that. Okay, so we know that if an angle is positive or negative, that is just telling us a direction in which to move. The next term we have is our coterminal angles, and a coterminal angle means that we have the same standard position. So I normally like to think of it as we have the same angle, just we're giving it a different name. And so in order to go ahead and find coterminal angles, we are going to add or subtract any multiple of 360 degrees. Okay, and the significance of 360 degrees, notice I had to use my degree symbol. That is super important. But 360 we know is a full circle. So my other option would be if I used 2 pi, and we'll get into that in a moment. But 2 pi represents a full circle in radians. Okay, so for example here, off to the side, I want you guys to write number 1, 30 degrees. Okay, so just to kind of demonstrate once again, if I was graphing this, I know that it is in quadrant 1. When we are graphing, and we'll spend a lot of time doing that, it really doesn't matter where in quadrant 1 you put it. It just needs to be in the correct quadrant. Okay, and that is my angle of direction, and this is 30 degrees. Now, if I wanted to write some coterminal angles, I could add 360 degrees. So another term for this would be 360 plus 30, which is 390 degrees. We also could take 30 degrees and subtract 360 from it, and I would get negative 330 degrees. Okay, all 3 of these are in this same exact standard position. Okay, now normally the reason why we use coterminal angles is to make angles in terms of being between 0 and 360, but occasionally we will change it in a different way. So our second problem here, let's say we had negative 58 degrees. Okay, if I added 360 to that, I would get 302 degrees. If I subtracted 360, I would get negative 418 degrees. So the whole concept here is that these are all equivalent to each other. They are all coterminal angles. So I've mentioned radians a few different times here. There we go. It was crooked and bugging me a little bit. So we're really going to talk about radians today based on a unit circle. And kind of the way that I think about it, I think of degrees, it is like our native language. To me, it is English. Okay, that's how I think. Last year in Algebra 2, maybe you were not fluent in your foreign language of radians. So what you did, you converted everything into degrees. And that's not wrong. Okay, when I was stuck in Mexico, I'm not fluent in Spanish. I understood things though because I would go ahead and translate in my head what that word was in English. Now our goal this year is to be fluent in our foreign language, so we want to get to the point where we can just think in terms of radians. And this is important because in calculus, they work primarily in radians, so we really need to be aware of that. So we're going to go ahead and use what we call the unit circle. And the important part about a unit circle is that we have a radius of 1. So I'm going to start by just reminding us that these are our 4 quadrants. Okay, I also just want to remind us this is our positive x axis, or just this is the x-axis in general, this is our y-axis. So I'm going to start off by going all the way back to geometry, and we're going to say C equals 2 pi r. So that's telling me that the circumference of a circle is equal to 2 pi times r. Well, a unit circle is a specific circle that has a radius of 1. So I'm going to go ahead and substitute 1 in for r, and I get that the circumference is 2 pi. Now, we know if I'm thinking about this technically, a circumference is really 360 degrees. So 360 degrees is equal to 2 pi. And so sometimes we'll see a little r written for radians. Normally, if we don't see anything written, that means it's in radians. So if we look at this, if I actually divided both sides by 2, that gives us that 180 degrees is equal to pi radians. And so the thing that I really want to stress to us is that pi is a semicircle. So whenever we're thinking about a value now, like let's say we had 90 degrees, we'd have to think, okay, how much of a semicircle is that? And we know that's half of a semicircle, so it would be equivalent to pi over 2 in radians. If we had something like 45 degrees, we know that's 1/4 of a semicircle, so that would be pi over 4. And the thing that I want to stress to you guys, one of the big things about today is just knowing what quadrant something should be in. And it doesn't matter if we know like the exact placement, we really just need to know the quadrant. So moving back over here, I'm going to go ahead and label the negative x-axis as pi because that is, actually, why don't I write that closer over here? But pi is a semicircle. And I know that this would be 0 and it would also be 2 pi. Those would be coterminal angles. Up top, we said that that's half of a semicircle, so that would be pi over 2. Down in the negative y-axis, that would be 1½ semicircles, so that would be 3 pi over 2. And then we're going to have things like we said, 1/4 of a semicircle right here is pi over 4. And we can kind of imagine that we can put a ton of different angles on here. We're not going to go ahead and do that. I think we can kind of figure it out. But we are going to spend some time here determining what quadrant something should be in. So on the next page here, we are going to determine what quadrant. And so, just a reminder, we have quadrants 1, 2, 3, and 4. And our first question here is going to be pi over 6. So if I'm just thinking about this, pi over 6, 1/6 of a semicircle would take me somewhere about here. Okay, because we always start at the positive x-axis and then move counterclockwise because it is a positive angle. So I'm going to say that that should be in quadrant 1. Okay, number 2, I have 2 pi over 3. This coefficient of 2 over 3 is telling me 2/3 of a semicircle. 2/3 of a semicircle would take me into quadrant 2. Okay, so we really have to transition away from us thinking about pi as 3.14 and we're thinking about it in terms of semicircles. If we had something like 3 pi over 5, once again, if I start on the positive x-axis, 3/5 is bigger than 1/2 and less than 1, so it would be somewhere in quadrant 2. Number 4, what if we had 7 pi over 5? I hate mixed numbers, I think they're dumb, but in this case, I actually think it might be helpful to think of it as 1 2/5 semicircles. Okay, because I'm going to go 1, and then 2/5 of a semicircle isn't quite going halfway, so I know it would be somewhere here in quadrant 3. Number 5, what if we had negative 11 pi over 3? So I'm going to think of this as negative 3 2/3. So first of all, since it's negative, that is changing the direction I'm moving. Now I'm going to move clockwise. So I'm going to move 1, 2, 3 semicircles, and then 2/3 of a semicircle would end up over here somewhere in quadrant 1. Okay, and our final one, what if we had something like negative pi over 2? So if I was moving, I know I need to move clockwise, and pi over 2 is half a semicircle, which leads me right here. And that might look a little bit confusing because technically this is not a quadrant. But you guys may remember the term from last year that we use, quadrantal. That means that it is not in a quadrant. It is either on the x or the y axis. Okay, so this is a very important term for us, and we will see in pre-calculus that the trigonometric ratios of the quadrantal values become super, super important. So the next thing that I want to do here is let's quickly just think about some coterminal angles with radians. We already said that we would add 2 pi. So if I have something like negative pi over 4, if I added 2 pi to that, I would get 7 pi over 4. If I subtracted 2 pi, I would get negative 9 pi over 4. So we would say all 3 of those are coterminal angles. They share the same space, the same standard position. They just have different names. The other thing that I think that is important for you guys to know, like if you're someone that hates fractions, you want to put that in your calculator to add them, just a reminder that we should not put pi in the calculator, because we know pi, even though we're thinking of it as a semicircle, it really is an irrational number, and it will mess up trying to convert something into fractions. So if I wanted to do negative 1/4 plus 2, I would just put that in and then make that the coefficient of pi. So you guys might be thinking, okay, yeah, that's great, Miss Miklos, but what does a radian actually represent? And a radian is the measure of a central angle theta that intercepts an arc S equal in length to the radius r of the circle. So that sounds kind of weird, so let's actually break it down a little bit. Okay, so here we know that that would be like the radius. Okay, that's r. There we go, that's theta, that's our central angle. And this is S, that's the arc length. Well, when S is equal to the radius, when that arc length is equal to the radius, that's when we have 1 radian. And probably the easiest ones for us to know, we know that a semicircle is pi, so this is like 3.14 radians. And this is like 6.28 radians. I made that look way more confusing than it needed to be there. Okay. Because that's 2 pi. So if we think about it, 2 radians is a little bit more than half of pi. And we know that that is the quadrantal value. 3 radians would be somewhere over here. 4 radians, 5 radians, and last but not least, 6 radians. And I know mine isn't to scale by any means, but hopefully it gives us the idea of what quadrant things would be in. I think the easiest way to remember where something would be to convert these quadrantal values into decimal values and determine, okay, is it bigger, is it smaller? So once again, we are going to play what quadrant is it? So if we just saw something like 4, okay, I don't see any degree symbol here, so I know that that is in radians. So if we look, I should probably label our quadrants again. 1, 2, 3, and 4. Okay, and I can see here that it looks like it is in quadrant 3. Okay, 6 radians. If I look at this here, it appears to be in quadrant 4. What about 2.1 radians? If I look, 2 radians is here, 3 radians is here, so I know that it would be somewhere in this mix. So I'm going to say it is quadrant 2. Okay, here's one that's a little bit tougher. What about 3.2? Okay, I mentioned earlier that it's really helpful for us to use the quadrantals to determine where we should go. If this is 3.14, I know it's bigger than that, so that means it has to be down in quadrant 3. And last one, what if we had something like negative 2? We know negative 2 means that we are going to be working this direction. And I know that this would be like equivalent to negative 1.57 radians, because this would be negative pi over 2. Negative 2 radians is bigger than this, so I would need to continue to move here into quadrant 3. Another way we could have done this is I could have taken negative 2 and added 2 pi to it, and it would have given me, let me actually do that. Okay, so if I have 4.28, why am I making this harder than it needs to be? So if I did 4.28, I could see, okay, well 4 is in here, and I could determine, okay, it's between 4 and it's between 1.5 pi. I could determine what 1.5 pi is, and that's about 4.6. So I could definitely see, once again, that it is in quadrant 3. So some conversions between degrees and radians. And you guys did this a lot last year. Remember, the key for this year is we're really trying to think in terms of radians, but sometimes this is helpful for us to know. So the important thing for us to remember is that pi radians is equal to 180 degrees. So that means if I am converting from degrees into radians, I multiply by pi over 180 degrees. And the significance of that is that I know that pi and 180 are equal to each other. So this is just like multiplying by 1. If I'm converting from radians into degrees, I multiply by 180 degrees over pi. So let's do some here. Let's say we had 30 degrees. So I would multiply here by pi over 180 degrees. When I simplify this fraction, I know 30 goes into 186 times, so my answer would be pi over 6. If we had negative 45 degrees, I would multiply by pi over 180. When I simplify this, I know 45 goes into 184 times, so I get negative pi over 4. You guys may be thinking, well, why don't we do this all the time? This is super easy. Why do we need to think in terms of radians? And the reason is even though this is easy, it does take some time. And you guys are going to be expected to do some stuff in radians at a very, very quick pace, okay? So if I was converting 90 degrees, pi divided by 180, I would get pi over 2. Okay, so when we are converting into radians, I am just simplifying the fraction as much as possible. Okay, number 4. Sorry, my cat decided to lay right on top of my problems. There we go. If we have 2 pi, I would need to multiply this by 180 over pi. Notice my pi's cancel each other out, and I get 360 degrees. I cannot stress how important it is for us to label those degrees. Okay, if we had something like negative pi over 3, I would multiply it by 180 over pi. Notice my pi's cancel out, and 3 goes into 180 60 times, so I'm going to get negative 60 degrees. Okay, so that's how we convert back and forth with radians and degrees. Okay, so our next random topic, and you guys are noticing today everything is kind of random, and the reason is these are really all the building blocks for what we're going to be doing all chapter long. And trig really goes on for quite a few chapters. Even if you don't think we're doing trig, trig somehow manages to make its way in there for the rest of the semester. So I want to talk about this weird DMS and DD. Okay, DMS is degrees, minutes, seconds. DD is just normal degrees. Okay, so you guys may be wondering what are degrees, minutes, and seconds. You know what degrees are. but we're going to say 1 degree is equal to 60 minutes. So we see this little like apostrophe, and that is a minute. Okay, so 1 minute is equal to 1/60th of 1 degree. Okay, so this is just another way, instead of giving a decimal, that we will often see things written. And if we see 1 second, okay, we see that 2 like apostrophes, it looks like a quotation mark. We know that's really equal to 1/3600th of a degree, because there are 60 seconds in 1 minute, there are 60 minutes in 1 degree. So we're going to do some problems where we need to actually convert from one way to the other. Okay, so if I'm converting from degrees, minutes, seconds into degrees, which is most often what we do, there's a few different ways we could do it. If I had 30 degrees and 45 minutes, I could take this 45 and divide it by 60, and I would get 30.75 degrees. Okay, so not that tough, but I do want you guys to know that there is another way that we could do it. If you guys have your calculator, you could go ahead and press 30, and then if you guys press second apps, that gives us the key that says angle. Okay, and if you notice in the angle menu, number 1 is the degree symbol. Okay, so I would need to put that in, so that would be 30 degrees, and then I would need to put in 35, and I would need to go back to that menu, so I'm pressing second, apps, and if you notice, number 2 is the minute symbol. Okay, so I would put that in and press enter, and I would be good to go. So it really doesn't matter which way you choose to do it. I actually think the first way is easier, but if we want to use our calculator, it is a marvelous thing that does really cool stuff, so we could get away with that. So number 2, we have 83 degrees and 18 minutes. When I put that into my calculator, either way, whether I'm doing 18 divided by 60 or if I'm doing that angle menu, I get 83.3 degrees. Okay, so if we see this chapter, don't let it confuse you or mess you up. And just for fun, let's go ahead and look at one where we are changing it from degrees into degrees, minutes, seconds. So if we had something like 230.6 degrees, if you guys actually did 230.6 degrees, and then go back to that magic menu, second apps. If you choose option 4 has like an arrow and it says DMS. What this is going to do is automatically convert it for you. And so it would tell us it was 230 degrees, 36 minutes, and 0 seconds. So that is section 4.1. Definitely basic trig stuff, all stuff we've learned before for the most part. But it's just really good practice for us to make sure that we're getting all these things correct. So now we're going to go ahead and transition into section 4.2. So if we look at this, okay, we're talking about the trigonometric functions, and we should definitely recognize sine, cosine, tangent, cotangent, secant, cosecant. And in previous years, we've really focused on looking at the triangles. And guess what? That's what we're going to do next class. Okay, but today I just want to give us another option of finding trigonometric ratios. And for some of you, you might like this way better than using triangles. Okay, others of you might like triangles better, and that's great. I personally like the triangles better, but I think that if you're someone that is just really good at memorization, this could be a cool method for you. Quite honestly, we know we need to memorize whatever method we use. But I will say that we're going to use this particular method when we are dealing with all of the quadrantals. So even if you're going through this going, this is dumb, I just want to make a triangle, that's fine, but know that there is a reason we are learning this, and we are definitely going to do that with our quadrantal values. So I'm going to kind of zoom in here. So it says let t be a real number. So t, we know it's always, we need an angle connected to our sine or trig, whatever trig function we're dealing with. So t represents our angle here. And let xy be the point on the unit circle corresponding to t. So basically, instead of memorizing all these values, what we're going to memorize is that sine is the y value of the ordered pair, cosine is the x value of the ordered pair, tan is y divided by x. And we know that cotangent, secant, and cosecant are all reciprocal values. So I'm just going to make a note here, like on cosecant, y cannot be equal to 0. On secant, x cannot be equal to 0. And on cotangent, y cannot be equal to 0. For tangent, x cannot be equal to 0. So that just gives us a little idea of our restraints here. Now, some of you guys might be wondering why this actually works, and the reason is we know in a unit circle, our radius is 1. So if I go ahead and look at a unit circle here, kind of a rough circle, but that's okay. Let's call this x, y, and this angle right here is t. I'm actually going to zoom in even more here for this. We know that this length right here is our radius, and on a unit circle, I know my radius is 1. Okay, if I draw straight down, I notice this forms a right triangle. This is our x value, and this would be our y value, because I know that's telling me how far over I'm going, how far up I'm going. So based on things that we've previously learned, I know sine of an angle, sine is opposite over hypotenuse. Notice I would get y over 1, or sine is equal to y. Okay, for cosine, I know cosine is adjacent over hypotenuse, so I would get x over 1, so the cosine is equal to the x value. For tangent, I would do y over x, so I would get just y over x in this case. And if we look, those are all the values that we get. So mathematically, that's why it works. Okay, we just need to somehow memorize that sine goes with y, and that's going to be like a relationship that we see again and again and again. Okay, and this is super dorky, and it probably won't make sense to half of you. But the way I remember is that the vowel sound in sine kind of sounds like y, sine, y. I don't know. It's dumb. But think of something dumb like that will help you remember it, and you'll be in good shape. So for today's notes are going to seem really easy because I'm giving us all of these ordered pairs. But I just want to point out a few things to you. Okay? With all of our quadrantal values, if we start here, we know that the radius is 1, so that ordered pair is 1, 0, because I'm going to the right one and I'm not moving up or down. 0, 1 means I'm just going straight up 1. Negative 1, 0 means I'm going to the left 1. 0, negative 1 means I'm going down 1. If we look at these ordered pairs, these are the 3 ordered pairs that I need to have memorized. Okay, pi over 6 is radical 3 over 2, 1/2. Pi over 4 is radical 2 over 2, radical 2 over 2. Pi over 3 is 1/2 radical 3 over 2. And honestly, guys, if I know these 3, if we look, all the ones in quadrant 2, everything that has a denominator of 3 has the same ordered pair I can even move here to quadrant 3 or quadrant 4. The only difference is the direction. So I know if I'm going left and down, both of those values should be negative. If I'm going to the right and down, the x should be positive, the y should be negative. Okay, so we really just need to memorize these 3 ordered pairs and the quadrantal ones, obviously. But if I know these 3 and I can memorize direction, then we're in good shape. So today's going to seem super easy because we have those values in front of us. It gets a little bit tougher when we have to have them memorized. So number 1 says t equals pi over 6. So first thing I'm going to do, if we look on our graph here, pi over 6 has an ordered pair of radical 3 over 2, 1/2. So I'm just going to go ahead and write radical 3 over 2, 1/2, just to remind me what I'm doing. And I need to find all 6 trigonometric functions. So I'm going to start with finding sine, cosine, and tangent. Notice we never write one of those trig functions all by itself. We always need to have an angle after it. Okay, so sine of pi over 6, we said sine is the y value, so sine is 1/2. Cosine of pi over 6 is the x value, so it would be radical 3 over 2. Tangent of pi over 6 would be y over x. So let's just kind of think about this for a moment. If I did 1/2 divided by radical 3 over 2, I would end up with 1 over radical 3, which we know is radical 3 over 3, because we need to rationalize that. We also could have gotten that if you just went ahead and multiplied by the reciprocal. No, just kidding. We would get this regardless, but I know that we need to rationalize. Okay, so now working backwards here. Cosecant, we know is the reciprocal of sine. Cosecant would be the reciprocal of 1/2, which would be 2. Secant is the reciprocal of cosine. So I would get 2 over radical 3, which we know is 2 radical 3 over 3. And cotangent of pi over 6 is going to be the reciprocal of our tan value, so I just get radical 3. So once again, this is just based on memorization. We just need to have all those angles memorized. So number 2, t equals 5 pi over 4. So if we look over here, the way that I personally think is easiest to do it, I know that our ordered pair for pi over 4 is radical 2 over 2, radical 2 over 2. And I need to think, what quadrant is pi over 4 in? And that would be 1 1/4 of a semicircle, so that's in quadrant 3. I know quadrant 3 is going to the left and it's going down, so it's going to be negative and negative. So if I am going through this, I'm going to say the sine of 5 pi over 4 is equal to negative radical 2 over 2, because that is our y value. The cosine of 5 pi over 4 is going to be negative radical 2 over 2, because that is the x value. The tangent value of 5 pi over 4 is going to be y over x. When I put anything over itself, it is equal to 1. Cosecant of 5 pi over 4, the reciprocal of negative radical 2 over 2 is just negative radical 2. Secant of 5 pi over 4 is negative radical 2. And cotangent of 5 pi over 4 is going to be the reciprocal of 1, which is 1. Okay, so once again, if I have these values memorized, it does not take me super long to do all of this. Okay, I want you guys to all put like a star or circle number 3. This is the one that we are going to have to work with the most. Okay, quadrantal. I know pi is a semicircle. So if I'm thinking about what would this ordered pair be, obviously we can see it's -1, 0. But if I'm just using common sense, I know that means I'm moving to the left and I'm not moving up or down. Since our radius is 1, that means that I'm moving to the left 1, and our y value there has to be 0 because I'm not moving up or down. So if I'm doing sine of pi, I know sine is equal to the y value, so it would be 0. Cosine of pi is equal to the x value, so that would be -1. And tangent of pi is equal to y over x, which would be 0 over -1, or 0. Cosecant of pi, the reciprocal of 0 puts 0 in the denominator. We know we cannot divide by 0, so we would write that this is undefined. Secant of pi, the reciprocal of -1 is -1. And the reciprocal of tangent is cotangent. The reciprocal of 0 is undefined. Okay, so the reason why I wanted us to star this is the type of angle that regardless of what our favorite method is, we are going to use this way in order to figure out those values. Okay, last but not least, we have t equals -pi/3. If I look back, and if I have this memorized, pi/3 is an ordered pair of 1/2 radical 3/2. Now, I know pi/3 would be in quadrant 4, because I'm sorry, it's -pi/3. I know in quadrant 4, that means we're moving to the right and down. So that means that my x value will be positive and my y value will be negative. So my ordered pair in this case is 1/2 negative radical 3/2. So if I'm finding all these values, sine of -pi/3, we know sine is the y value, so I have negative radical 3/2. Cosine of -pi/3. I know cosine is the x value, so it would be 1/2. Tangent of -pi/3. If I have negative radical 3/2 divided by 1/2, I end up getting negative radical 3. So now if we do all the reciprocals, cosecant of -pi/3 would be the reciprocal of -2 over radical 3, which would be -2 radical 3/3. The secant of -pi/3 would be the reciprocal of 1/2, which is 2. And the cotangent, just writing something weird there, the cotangent of -pi/3 would be the reciprocal of negative radical 3, which is negative radical 3/3. So the whole thing for us to remember is that we really need to have these 3 ordered pairs memorized, and we need to know what sine, cosine, and tangent are all equal to, because we know what the reciprocals are. Okay, so that's what it comes down to. We need to have those things memorized.